Gear cutting on the shaper with a plain parting off tool. This is possible as can be seen on this photo showing a PVC pinion. V equals 9, M3, pressure angle 20 degree, shifting 0.6. The tooth head diameter is reduced, HA equals 0.9 module due to the sharp head. So the DA is 36 mm. The span measure W key equals 14.9 mm. A link is given for a video that explains all these figures. These figures was obtained from the filengrène software. A link is given in the description for this free software. The parting tool is 2 mm wide with a rounded nose. I've already shown you a video how to cut through involute gears on the shaper using a one-tooth rack. The link is given in the description. This rack tool has 20 degree pressure angle. But how is it possible to cut with a plain parting off tool having 0 degree pressure? Here is the explanation. On this photo you can see an involute profile pushing a rack flank. The rack flank is a plain line perpendicular to the line of action. A link for a video about the how and why of gears is given in the description. The pressure angle is near 50 degrees. Look at the video. The rack is moving in the vertical direction. The black line is the line of action, the black circle, the base circle, and the pressure angle now is about 50 degrees. We can see that the meshing is beginning here and along the line of action, finishing there. Between the two black indexes, we have, of course, the well-known driving length. What happens now if we use a 20 degree pressure angle for the rack? The beginning of this contact is here, and we can see that there is a new line of action, the green one, and the end of the meshing is there. The line of action is so with an inclination of 20 degree with the same involute that was meshing with the 50 degree rack. Now the pressure angle is 0 degree, and we can see that the driving is still possible, but the new line of action is the blue one. The meshing is finishing there. We can see that there is only a point contact on the rack. So if we use a single point rack, we will obtain the same line of action. This is used for cutting gears having a very big module. Here you can see 4 gears having the same number of teeth and the same shifting coefficient, but different pressure angle: 2.5 degree, 10 degree, 20 degree, and 30 degree pressure angle. But now it's not the PCD of the base circle of the gear that must be rolling without slipping on the tension wire, as shown on the drawing. The routine is almost the same as the one already used on the shaper. The great difference is that it's not possible to adjust the depth of cut for a finishing cut, as was the case for a trapezoidal tool. We must take the whole depth, usually 2.25 module, but 2.15 here, to avoid a sharp tooth, as already explained. Here is the machine at work. and the result for the first between teeth space and also the whole raft gear. It's now possible to take a span measure W key here and the finishing cut V equals W key here less W key, so 16 less 14.9, this equals 1.1 millimeter. This must be taken by a rotation of the gear blank, the transverse movement being at rest. This can be done with a variable length linking rod by turning the center screw as seen on the photo, showing you also the caliper used. It's better shortening the link than lengthening for the tool to take a leading cut, this being the best cutting situation. Of course, the cut is now made only until the mid-throw of the transverse movement, as beyond no stuff will be cut. The gear was then checked in a running test. Look at the video. Here the PVC wheel is made with a parting off type tool. The running is still good. The power running satisfactory too. This process seems to be of low interest relative to the use of a trapezoidal tool. I've described it for two reasons. First, because it explains the principle used for cutting gears on a milling machine with a plain slitting saw having rounded teeth, thoroughly described in another video. Second, because it explains also how a single point-handed tool can be used to cut internal gears, also thoroughly described in another video. A question is also arising: how to cut gears having 20-degree pressure angle with a tool having a different pressure angle, and why? For this, the pressure angle of the tool must be less than the one of the gear to be cut, but the tool must be adapted. For example, a 14.5 degree standard tool can be used because the tip width is too large for cutting 20-degree pressure angle gear. So this seems of low interest unless if we use a standard tool. This tool does exist as standard lozenge shape carbide with 35-degree tip angle, so 17.5 degree pressure angle, as shown on the photo. I've used this tool to cut 1 mm module gears with good results, and the tip radius is 0.4. I also cut 1.25 module gears with this tool, but now two problems are appearing. First, the tip radius is too small, as 0.4 in place of 0.5, but this is of low importance. The depthing must be made with the adjustable linking rod, as seen previously, but now the rolling cylinder diameter is not the base circle, so a calculation must be made from the span dimension. Now the last depth of cut V must be multiplied by the ratio dn divided by db, with dn being the new PCD and db the base circle. Why a new PCD? Because the standard one, d equals m multiplied by z, was for 20-degree pressure angle, and now the pressure angle is this 17.5 degree. So the new PCD dn equals d multiplied by cosine 20 degree divided by cosine 17.5 degree. But the difference in diameter is only 1.5%, so negligible. Now a pinion module 1.25, 18 teeth, cut with a standard carbide tool, running with a standard gear. The end running is very good. And the power running very good too. Look at the video.